please hit subscribe.
This problem appears at the 2019 Mathematics Questionnaire of the qualifying examinations for applicants for Japanese government or MEXT scholarships for the specialized training category. The answer key and the original questions are linked in the description. In this video, we will solve questions 6 to 9 of problem 1. Question 6. Let the sequence a sub n be a geometric progression satisfying a sub 1 plus a sub 2 plus a sub 3 equals 14 and a sub 2 plus a sub 3 plus a sub 4 equals minus 42. When we denote the first term of a sub n by a and the common ratio by r, we have a equals blank and r equals blank. This problem we are given the first four terms of the progression, the geometric progression. That's because we are given the first term a and the common ratio r. So the first four terms would be ar squared, and ar cubed. They are denoted a sub 1, a sub 2, a sub 3, and a sub 4 respectively. We are also told that the first three terms add up to 14. So that's a sub 1 plus a sub 2 plus a sub 3 equals 14. Now we know that a sub 1 is just a sub 2 is ar, and a sub 3 is ar squared. Now we can factor out a, and we are left with this expression. Let us call this double star. The other condition that was given is that the sum of a sub 2, a sub 3, and a sub 4 is minus 42. We know that a sub 2 is this, a sub 3 is this, and a sub 4 this. So we replace them. Now we can factor out a sub r, and we will have star. Now we divide star, the expression star, by double star. On the left side, we divide this by this. We notice that this cancels with this, and a cancels with a. So on this side, we are left with r. On the other side, we have this and this. We get the quotient, negative 42 divided by 14, and we obtain minus 3. And therefore, r is minus 3. Now, let us use double star to obtain a. Here, we just replace the r with the known value. So, r here is minus 3, r squared is minus 3 squared. And here is 14. Simplify this, we get 7, and therefore a times 7 equals 14, and a equals 2. Let a equal 1, 0, minus 1, b equal minus 2, 2, 1, c equal x, y, z, where x is greater than 0, and the magnitude of c be 3. When c is perpendicular to both a and b, then x equals blank, y equals blank, and z equals blank. For this problem, we just write the given first. This, and this are from the given, as well as this. Now the given also tells us that a is perpendicular to c and b is perpendicular to c. What this means is that if we take this, we get the following. A is perpendicular to c means that the dot product a dot c is 0. We also know how to express a dot product in terms of the components of a and c. That is just the product of each of the components summed together. So let's do that. So a and c, so the product of the first component is x times 1, we get x. The second component is y times 0, we get 0. And the third component's z times minus 1, we get minus z. We also see that the vector b is perpendicular to vector c. So their dot product is also 0. And again, the dot product can be expressed in terms of the components of b and c. So the first component's minus 2 times x is minus 2x. The second component is 2 times y, that's 2y, and the third 1 times z it's just z. Furthermore, we are told that the magnitude of c is 3. Therefore, c equals, or rather 3 equals the magnitude of c, and we also know how to express the magnitude of c in terms of its components. That is just the square root of the sum of the squares of the components. So that is x squared plus y squared equals z squared. We get the square root of that. If we just remove the radical by squaring, we obtain this. Now, we want to eliminate z from equations 2 and 3. And the way we do that is we use this. Because 0 equals x minus z, we can say that x equals z. So that is from this, 0 equals x minus z. Furthermore, if we substitute this into 2, we get 0 equals this plus this, and now we replace z with x. So we get this. We'll simplify this a little bit. We combine minus 2x and x into minus x, and we retain 2y, and we move this minus x to the other side. We get this, which is equivalent to saying that y is 1/2 of x. Now this is good because we can express z in terms of x and y in terms of x. So we can replace the y's and the z's with x. From the previous slide, we know that z equals x, y equals 1/2 x, and 9 equals x squared plus y squared plus z squared. Now we replace the y and the z with the x's that we got here. So 9 equals, this term is retained. This is replaced with 1/2 x. 1/2 x squared is 1/4 x squared. Z is replaced with x. So z squared is x squared. We add all these, we get 9/4. And now if we try to solve for x squared, we can cancel the 9's, and we get 4 equals x squared, which means that x equals plus or minus 2. However, we are also told that x is greater than 0, and therefore x must be 2. Then we use 1 to obtain z, which means that z equals x equals 2. For y, we use equation 2. We have y equals 1/2 x, and because x is 2, y equals 1. Question 8. Let M denote the midpoint of the side BC of a triangle ABC. When BC equals 8, CA equals 4, AB equals 6, then the cosine of angle ABC is blank and AM equals blank. Let us first draw the given. The given is a triangle. We label it ABC. We are told that the midpoint of BC, which is this side, is called M. So we put M there. Now, BC is 8. Therefore, BM is 4 and MC is 4. Because the midpoint means the point where the line segment is bisected, or in other words, divided into 2 equal parts. So 8 is divided into 4 and 4. CA is given to be 4. AB is given to be 6. Now we are interested in angle ABC. Angle ABC is this angle. And the line segment AM, which is this line segment. We can get angle ABC from the cosine law. We notice that we are given 3 sides. And if we take this to be our unknown angle, then the cosine law will read 4 squared equals the square of this side plus the square of this side minus 2 times this side times this side times the cosine of the included angle ABC. Now, we can solve for the cosine of ABC by solving this equation. First, we divide all sides by 4, so this one becomes 4. Here we have 36 divided by 4 is 9. 64 divided by 4 is 16. And here we can divide 8 by 4 to get 2. 2 times 6 is 12 times 2 is 24. And the cosine of the angle is here. Now we just rearrange this a bit. We move the 4 to the other side. That means we have 4, or rather minus 4 plus 9, which is 5, plus 16 is 21. And we divide all sides by 3. We get 7 minus 8, cosine of the angle. And if we just move this bit to the other side and divide by 8, we get this as the cosine of angle ABC. Now we want to find the line segment AM. Again, we can apply the cosine law for this smaller triangle. Now, for this smaller triangle, we see that the angle we know is this, and so this will be our other side, on the other side of the equation. So AM squared equals the square of this side, which is this, the square of this side, which is this, minus 2 times this side times this side times the cosine of this angle. However, we already know the cosine of this angle, which is 7/8. So we replace that with this, and this we replace with 48, this with 16, this with 36. We notice that we can cancel the 8's here to get 6. And now we have 6 times 7, which is 42. 36 plus 16 is 52. 52 minus 42 is 10. That is the square of AM, and therefore AM is the square root of 10. Question 9. The equation of the tangent of the curve f of x equals minus x squared plus x plus 2 at the point 0, 2 is y equals blank, and the area of the region bounded by the curve f of x, the tangent, and the x-axis is blank. From the problem, we know that f of x is this, and that the tangent is at 0, 2 for this problem. And let us call the tangent the line L. In general, any line can be expressed in the form y equals mx plus b, where m is the slope of the line and b the y-intercept of the line. Now, to find the slope, we can also use the derivative of f of x. The slope of the line at 0, 2 is the derivative of f of x at 0, 2. So that is f prime of 0. So let us find the derivative of f of x. F of x, or rather f prime of x, is equal to the derivative of this, which is minus 2x, plus the derivative of this, which is 1, plus the derivative of this, which is 0. And so we now have this derivative. If we replace the x with 0, because we're looking for f prime of 0, then we obtain this and this. Therefore, our slope is 1. We replace the m here with 1, and we get this. Now we need to look for the y-intercept b. At 0, 2, we know that this line is satisfied, this equation. So we replace y with 2, x with 0, and b with b. Now we can find b. Therefore, the equation of our line that is tangent at 0, 2 to the curve f of x is given by this. Here we replaced m with 1 and b with 2. Now let us find for the area that is being asked. First, we need to draw the problem. We are given this f of x. This is a parabola, and we will see that if we put this in standard form. To do that, we will have to complete the square. First, we need to take the negative sign out of x squared and x. So we get this. Inside the quantity symbol, we need to complete the square. And that means we have to add 1/4, because 1/2 of the second term's coefficient, which is -1, 1/2 of -1 is -1/2. We have to square that to get the third term. And -1/2 squared is 1/4. And that's how we obtain this. Now, because we added 1/4 here, and that's a negative, we have to add it outside as well. And so here we added a positive 1/4 to counteract the effect of the -1/4 in here. Negative 1/4. Now, this term here, these terms here consist a perfect square. And so we express that in terms of the binomial. So x minus 1/2 squared. Notice that this term equals this. So they are equivalent. These are equivalent expressions. And now here we have 1/4 plus 2, which is 9/4. That means that we have a parabola that is opening downwards because this is negative, and the vertex is at 1/2 9/4. So we draw that. This is our parabola, and this is our vertex at 1/2 9/4. Now we just draw the line. The line that we obtained is y equals x plus 2. That means that that line is increasing, so it's this direction. And it was also said that it's tangent at 0, 2, so it's tangent here. And now we are asked for the area bounded by this line, the parabola, and the x-axis. That area is this red area. To compute this red area, we notice that it is easier to compute this triangle and subtract this blue area. So to get the red area, we compute the area of the triangle bounded by the line and the coordinate axes, and then we subtract the area of this blue line, or rather blue region, which is the integral of the parabola from this point to this point. And so we do that. First is the area of the triangle. To find the area of the triangle, we need to apply 1/2 base times height. So let's find the base. This point here can be found by using this equation. We know that at this point, the value of y is 0. So we replace y with 0. That's what we did here. And we find that x equals minus 2. Therefore, this point is minus 2 is 0. Therefore, the length of this base is 2. That's why we have 2 here. Now, the length of the height is also 2, because this intersection here is 0.02 as given by the problem. So the area of the triangle, this triangle, is 1/2 times 2 times 2, which is just 2. Now the area of the blue region is given by the integral of the parabola, which is this function here. Now we just need to find this point B here, because this is the start of the integration. And the end of the integration would be at 0 here, x equals 0. So to find this point here, we just need to set y equals 0 again and use this function. So 0 equals this function. So 0 equals this, which is equal to this. So 0 equals this. Now, if we move this to the other side, we get this. We can now extract the square root from both sides, and we get this equals plus minus 3 over 2. Now we notice that this point is to the left of 0, and so this must be negative. So we will choose the negative solution. Now we obtain x minus 1/2 equals negative 3/2. If we move the 1/2 to the other side, we get that x equals minus 1. Now we know that the area that we're looking for is the integral from negative 1 to 0 of the function. And now we can compute this and subtract it from this, which is just 2. Here we just copied what we had in the previous slide. So the area of the triangle is 2. Now we are subtracting the integral. So because this is a negative sign here, we have an addition. And because this is a positive sign, we have a subtraction. And a positive sign, we have a subtraction. Then we just compute the integrals. The integral of this is 1/3 x cubed. This is minus 1/2 x squared, and this minus 2x. We just replace the upper and the lower limits of integration. So that becomes like this. If we simplify this, we obtain this 2 plus 1/3 plus 1/2 minus 2. The 2 and the 2 cancel, so we are left with 1/3 plus 1/2, which is 5/6. If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!